I in the middle. That'd be nice. Okay. I guess first thing we need to decide is when our next test is going to be. We're just going to break it down. We're just going to go sections 1 through 3. Okay, rather than do the whole chapter, we're just going to stop and do 1 through 3. So I like to chop things up into smaller pieces so then we can really go fairly in-depth in those pieces rather than have one test that we're supposed to get done in a 45-minute class period over 7 or 8 sections. I think that's kind of ridiculous. So 1.1 to 1.3 test. Okay. And so today I'd just like to just take a break and let's go back, take a look at some things. I've got some sheets here to help review with a little bit. And I would like to, if it's at all possible, get it done this week. I know it's a little bit of short notice, but do you think? Yes.
2 days this week?
Yes. Yes. Okay. So let's take a look at some things here. Okay. So we'll just kind of skirt through these sections here real fast. Section 1 was all about domain and range and restrictions on the domain. So you tell me, when do we need to restrict a domain? When there's 2 specific algebraic situations that we cannot allow to occur. Square roots and 0 on the bottom. Okay? So whatever function we have on the bottom, set it equal to 0, and whatever value that is, toss it out. Okay? Same thing with underneath square roots. I just had an example from pre-calc this morning that somebody was asking about. I think it would be a good thing for us to go over. So if we have f of x is equal to the square root of 2 minus x squared, what's the domain of that going to be? Well, let's think about it. Take what's underneath here, and let's put our condition. It's got to be greater than or equal to 0. So now what? Solve for a. Let's find a. Find x. I don't know where I got a from. So negative x squared is greater than or equal to negative 2, and I'm going to cycle up here to give me some more room. Now I've got x squared is less than or equal to 2. And now we can either square root this, but it gets a little bit confusing with the plus or minus and the less than greater than. So let's just stop and take a breather and let's take a look at a number line. Okay? So obviously from these values of x, we're looking for small values. Okay? And those values have got to be between what? Oh, 0 is going to be one of them. 2, not 2, but no, square root of 2. Because we don't have the a by itself quite yet. If I did square root that, or a, I'd have x is, I'm just going to go equals plus minus square root of 2. Because the less than greater than gets a little bit confusing when we deal with plus minus. So there's going to be my breakpoints between what works and what doesn't work. So I've got square root of 2, negative square root of 2, and it's going to be those points between. Okay? On square root of 2 and negative square root of 2, would it be open or closed circles on that? Closed. Well, because I have greater than or equal to, but also the square root of 2, if I plug it in, would give me 0, and I can square root 0 just fine. Not a problem. Okay? The next section we're just talking about, or the next portion of this, we're just talking about domain and range. Okay? So this kind of addresses some of those things I was talking about. Range on these, I guess I'm trying to decide how much I want you to use graphing calculators on these. Let's think about this. X squared, got this. My range is obviously y is greater than or equal to 0. Another way we could write this is we could say 0 to infinity. Okay? 1 over x is going to be this graph right here. I think you guys are familiar with that as one of your parent functions. True or not? When you see 1 over x, do you picture the graph or not? Okay. Okay. Again, that gives me, some background on what you guys, because different books focus on different things. This is not reflection on you guys or Mrs. Gunther or anything. It's just different books focus on different things. Okay. So where did I come up with this graph from? Well, 1 over x, 1 over 1 is 1, 1 over 2 is 1/2, 1 over 3 is 1/3. So then it's going to get smaller and smaller and smaller. We have graphed this before. If I get 1/2, I get 2. Plug in 1/2, I get 2. And then I'm going to end up with this down here as well. So then from there we can tell what our domain and range are. And they're both the same. They're everything but 0. Okay? So what we've got is, for my domain, we can say it a couple different ways, but we could even just say this, a set of x such that x can't be 0. That would be sufficient if we wanted to use set builder notation. If we wanted to use interval notation, we're going to go from negative infinity to 0, non-inclusive, so hence the parenthesis, joined with 0 to infinity. So I know sometimes people don't like set builder notation, but sometimes it's really handy because you can just describe what it is. Yes? You can use whichever one you want. You can use whichever one you want. Because sometimes just one is more convenient than the other. So you can just choose whichever you like best or is more convenient. Like in this case, I would probably use set builder. Just because it's pretty obvious. Don't use 0. Okay? And then the range is going to be exactly the same. Because my y values, I get all these negative y values. I don't get 0, but I get positive y values. Okay? So since sounds like we've need to kind of get a little bit more familiar with parent functions a little bit. I'm going to go ahead and do square root of x. We did that the other day, but let's just review it. 0, 0, 1, 1, 4, 2. You can just go ahead and plot some points, and you come up with that equation pretty well. Just orally, tell me what the domain and range are. Y is greater than or equal to 0. My domain, same thing. X is greater than or equal to 0. Okay. And now using our information that we've done with the last section, we can even do this one pretty nicely. If we rewrite that, negative x plus 4, we could look at this as a couple different ways. We're going to flip it over the y-axis, and then we're going to slide it. Okay? But this is one where it gets a little bit confusing because the order of operations inside. I don't want to go down this rabbit hole, but it appears that we would flip it over the y-axis and then slide it to the left 4. Right? That's actually not the case. I'm not going to get into it, but the order of operations inside is also opposite. You know, like I said, that inside horizontal causes opposite changes. the order of operations is also opposite as well. But I'll show you something that'll tidy this up. So what's going to happen is it's going to go ahead and go to the right 4, and then get flipped over the axis at some point. So, but let me grab a different color. This is one where maybe all our rules don't work the greatest, but that's what our graph should look like. Think about the original. How do I know that's what the graph should look like? Well, plug in 4. I get 0. Boom. Plug in 3. I get 1. Boom. Plug in 0, and I get 2. Okay? So the one thing I'll say is when we're dealing with more than one modification, or a stretch or a shrink or slide or flip on the inside, sometimes our rules don't work the greatest. Okay? So if it comes down to, hopefully you understand the battle I'm fighting right now. Should I let you use your graphing calculator to determine the range, or should I have you just come up with some values to determine the range? What should we do?
Graphing calculator.
Yeah. Hey, Zeus is letting his opinion known. And at this point in time, with everybody in favor, say aye. I thought it'd be aye. Okay, let's move on to some other things for now. Okay. Just a real quick review. How do you determine whether a graph is a function? Pass the vertical line test. For every input, it needs to have one and only one output, so that means you can't have two results from the same x value. Okay? Could you graph something like this? Okay? You just plug in values. So like these, you'd plug in some negatives into that. So we get -1, 1, -2, 4. I'm not supposed to plug in 0, but I'm going to give myself an open circle for that, just to let me know where to stop. Okay. 3 from 0 to 1. Well, that's easy. And then -x greater than -1. So then that's going to look like this. 1, I get -1. And then I end up with something like this. Okay. Piecewise functions. Flip, 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 flip. Okay. One thing we worked on too, real quick, is finding equations for piecewise functions. Well, you tell me, what is this right here? What's the equation for that? -1/2. How do we get -1/2? Let's look. Down 1 over 2. -1/2 x, and my y-intercept is 0, so we don't have to put anything from there. From 0 to 2, obviously 2, and then this one here, ooh, now we're going to have to use some maths here. 2/3, up 2 over 3x, and then this one, if we go back, we notice my y-intercept isn't going to quite land on a good point, so we're going to have to do some math. Okay, so let's just sketch this out down here. Y equals 2/3 x plus b. Let's pick a point we know. This is going to be nice. Let's go ahead and do 2, 0. And stop me if there's something you're like, wait a minute, how'd you get that? And then my b would be -4/3. Okay. That's section 1. Section 2. We had all of our different types of functions. A constant function. Linear. 2x plus 1. power, x to the fourth, polynomial, we did one of those the other day, rational, x over x plus 2, algebraic would be any combination of those, adding and subtracting and this, that, and the other. A polynomial, technically, x to the n, where n is a whole number. Where n's a whole number. So x to the fourth, x to the third, x to the second, x to the, you'll probably remember doing that. Trigonometric. And so trigonometric has functions like what? Sine, cosine. Do you know the other four? Cosecant and secant. Yep. Good. Which I won't quiz you at this point over those, but yes, those are. Was that a geometry deal or was that pre-calculus? Okay. Okay. So my guess is you've graphed all those things and looked at those. Maybe a little bit. Maybe the graph doesn't come right back to you right away, but you still graph those. Okay? Okay. Increasing, decreasing functions. Excuse me. Again, we're right back to having to decide how much we want to lean on our graphing calculators. I would say if I gave you something like the first four, I would like you to be able to do those without a graphing calculator. Okay? Why do I say that? I know you guys just looked like I ran over your cat. Okay? But the first one, that's obviously just x squared. Okay? Next one, 2 over x. It's the same idea here. It's just been stretched by 2. It's not going to change. It's increasing, decreasing. 1 over x squared. Well, it's going to differ from this one in a certain way. Where's the other side going to be? Top right, because I can't have, or top left, I'm sorry. I can't have negatives in that. So that's really reasonable to ask you to be able to sketch that, and just enough to identify the intervals of increase and decrease, and then this one is just that same thing. Okay. Odd and even functions. Plug in the opposite and it doesn't change anything. That gives you a y-axis symmetry. Plug in the opposite and it gives you an opposite result. That gives you origin symmetry. And then the tests of all these. Okay? Are they odd or even? Let's just pick one. How does that compare with the original? Opposite. So what does that tell us about the function? It's odd. Well, let's take a look at it. Great question. What do you think? Neither. It's not exactly the same. It's not totally the opposite. That's what we get. Okay? And then the last section was combining functions. Okay? So I'll tell you what, I will put these up here, and if there's any of them that you want to do real quick, we can. So I've got f of x is 2x plus 3, g of x squared of x, h of x is 1 over x. The bottom? Like this one here or these two? Bottom middle one. Okay. Let's take a look. I really don't want to zoom in anymore. Can you guys see that okay or not? Okay. So h of x is 1 over x. And I'm going to do g of x to that. So next I'm going to hang a square root on that. And then after that one I'm going to do f, which is take 2 times that whole thing and then add 3. So I'm going to start with one function, hang the next one on, hang the next one on, and now we can simplify it a little bit. 2 square root of 1 over x plus 3. There's really not much we can do to square root that. If we wanted to get rid of the square root on the bottom, I'm going to kick this over here just in interest of space. I would go 2 square roots of x over x plus 3. By multiplying top and bottom by square root of x, which you guys have rationalized denominators till you're blue in the face.
So would you want us to leave like that or rationalize it?
Let's rationalize it.
All right.
You've done that before, right? You're okay. You're okay. This now, and not to get personal, but you said this morning?
No.
Oh. Yesterday. Where's it you work again? Runza, okay. Their fries are the bomb. I'll always have Runza will always have a special place in my heart because my wife and I's first real date was on the way we went to Runza. That wasn't our first date, taking her out to Runza. So don't be critical. So. Okay. How'd you do on these type of problems? Where like on the bottom where we gave you something and then you had to figure out what the composition was. Okay, well. Okay, let's just take a look at it. So what we've got is we've got these 4 functions we can work with. A is the add 2 function, B is the square function, C is the square root function, and D is the times 5 function. One thing you could do if you wanted to is you could rewrite this in terms of just those 5 things, which in this case be 5 times x plus 2. Because there's a plus 2 function, there's a 5 times 5 function. So then the first thing being done is an A, and then we're doing a D to it. So a lot of this, if you rewrite it in terms of just those 4 operations, then it'll kind of solve itself. How would we rewrite x to the 4th in terms of all this? X squared squared, okay? So we have x squared squared. So then x squared is my b of x. And then I'm going to take that and do b again. Okay? And then this one, actually, we don't have to rewrite it. It's all there. So the first thing live the life of the x. If I plug in x, what are we going to do? Which function first? A. I'm going to square it first. So I'm going to go b first, then A, and then C. So live the life of the x. What's happening to my x? Okay? And then this last one. Ooh, honestly, I'm not seeing it. I wonder if it's a typo.
It's neither.
Okay. Well, okay, let's think about this. How do I add 4? By using just those things. Exactly. We'll do x plus 2, and then when we're done with that, we'll add another 2. I thought it was going to be something fancy with square roots or squaring or this, that, and the other, but we made it too difficult. It would be, we would do a of x, and then to a of x, we will add another 2, so we need another function a. Okay. I hope we're still recording. Okay. You got your vertical shifts, your horizontal shifts. We did all that inside in International House of Pancakes. You know that. Okay. I like these down here. Very similar to your homework, if not exactly the homework problem. So F is right here. I'm going to highlight F. Which one's A? 3. Yeah. Because this is minus 4. It's inside. It's going to be a horizontal change. It's going to be the opposite of what you think. So it's going to go to the right 4 units. So that would be 3. So I'm going to check that off. Boom. Okay. F of x plus 3. 1. Boom. 1/3 f of x. 4 because it's 1/3 as tall. Boom. Negative f of x plus 4. So this one's going to go 4 to the left and then flip. So 4 to the left and flip it over. Boom. Gee, I wonder what E is. I'm not quite sure. It's going to go 6 left, twice as high. 6 left, twice as high. Boom. Yes? That's a great question. Because my y-intercept has a y value that is now 1/3 of what that y value used to be. Because what's happening is that you're taking the old function, getting those results, and then taking 1/3 of every single y value. Okay? And the y-intercept is a y value. Okay? So like this, what's happening is this one, 1/3 of the way, 1/3 of the way, 1/3 of the way, 1/3 of the way. But this one doesn't move. Why is that? No. Because it's 0. 1/3 of 0 is 0. So it takes everything and compresses it closer to the x-axis, no matter where it's at. Great question. That's the stuff I like. Good. Okay, we won't do all of these, but here's, like this one, we take every point and move it to the left 2, because inside, horizontal shift, it's going to be the opposite of what it says. Okay, this one, half as tall, but based upon Kat's great question before, let's practice this. So this one, right now it's 1, 2, 3, 4. Now it's going to be half as tall. This one is going to be 1. This one, 1/2. This one, 0. So everything goes half as tall. It pulls it down towards the x-axis. Okay. C, we might want to do this one in 2 steps. The negative on the inside is going to flip it which way? Across the y-axis, because it's my inside, it's going to be a horizontal change. Okay? So I'm going to do this one in 2 steps. That point doesn't move. This point comes over here. And this point also comes over here. And this point goes over here. Okay? I'm not going to draw that because it's just going to muddy up my graph. But that is my first change. And then what's going to happen from there? Down 1. Here we go. Boom, boom, boom. Looking at my blues. There you go. It's been flipped, slid down. D. It grew? Shrunk? Make up your mind. Well, what's it going to do? Okay. How come? It's going to be a horizontal change. It's going to be the opposite of what it says, or you need to double your, you can plug in smaller x's to get the same result. So everything's going to move in closer to the to the y-axis. This is 2 away. Now it's 1 away. That's 4 away. Now it's 2 away. That one stays the same. This one moves in. So everything, I'll plot this just so you can see it visually. Everything went. Got it? You okay? Good. Okay. Now what do I do with each one of those? Up 3. Okay. What's this equation? The graph of x squared plus y squared equals 49? That's a circle. Up to, what should I do? Up to, y is going to be my deal. So what am I going to have to do? That's going to be y. Now this one's a little different because, we don't have the y by itself. So it's input into both my x and input into my y. So they're both going to be opposites. It's going to be minus 2 squared, right 3, minus 3 squared equals 49. Okay. We'll skip to this last one here. Y equals square root of x up 4. Well, it's going to be a plus 4 on the outside. Left 2 is going to be plus 2. No, but wait a minute. It's left 2. Isn't that negative 2? So it's got to be opposite. Okay. We need to be sponsored by IHOP. I actually, about 10 years ago, I tried to actually take some pictures of my class with, and post it and get the attention of International House of Pancakes. We never did, so we never got any gift certificates or gift cards or anything. I was a little disappointed. Yeah.
Yeah.
In IHOP. Bring our own little whiteboard. Okay. Okay. Let's start this Friday. Because my guess is just from your body language and stuff, if I did it tomorrow, you guys would just freak out, right?
Oh, that'd be fine.
Okay. Or would tomorrow be a possibility, or do you want another day? Okay, so let's start it Friday. I don't know if we'll be able to get it done. We'll cross that bridge when we get to it. But I usually won't go Fridays. But I'm kind of making some changes based upon kind of how some things are going, and so kind of puts me in a situation. Let's start it Friday. So the way to do this, look back over your stuff from 1-1 to 1-3. If you got any questions on things, after you practice some things a little bit more, bring them in. Maybe I can shorten something up a little bit, and then so we can get it done on Friday. We'll have to see. Okay? I want to show you one problem today that popped up. Get your, well, we won't need it quite yet. We'll need my phone. My feed on Facebook, well, first of all, it's amazing the algorithm to go ahead and decide what they show you. It's very interesting. Maybe one day we can talk about that. But let's see if it's reset here. Yep, it has. So I need to go like this. Okay. So here we go. Stuff like this pops up on mine, and it really intrigues me. So as they say, a Boeing 747 carries about 63,500 gallons of fuel. Where do they put it? This is a 60,000-gallon water tank for reference. Does that seem right? First of all, can you believe everything that you see? Absolutely not. So for me, I looked at this and I'm like, that can't be right. That can't be right. And then I thought, you know what? This is a perfect graphing calculator problem. So here's what we're going to do. We are going to write a function that'll give me the volume based upon a certain height. I've done the research on this problem, and I found out the diameter of that tank. The diameter of that tank is surprisingly small. It's not like your typical grain bins you see around here. The diameter is 24 foot 9 inches. Okay? So what I want to do is I want to write a function. Here's my plan. I want to write a function for the volume in gallons of this water tank and find out how tall the water tank would have to be to hold that many gallons. Make sense? Okay? So what's the formula for volume of a cylinder? The area of the base times the height. More specifically, how do we find the area of the base? Circle. Come on. Area of a circle. Pi r squared. You know it's got a pi in it because it's a circle. You know it's got a r squared in it because we're finding area, which is squares. Okay? So there's my formula for the volume of a tank. Okay? So let's do this. Pi radius, I've already done the calculations here. It's 12.4 feet squared times my height. I'm going to let my height be my variable that we're going to put in my graphing calculator. Okay? But right now, don't type anything in yet because we got to make some modifications yet. I appreciate you wanting to get ahead of time. But this right now is in cubic feet because this is feet squared gives me square feet times height in feet gives me cubic feet. Is that what I want, cubic feet? What do I want? Gallons. So then we've got to ask ourselves. You guys might know this. I don't know if you do or not. I personally find it an amazing stat. But if we have a cubic foot that's 1 foot by 1 foot by 1 foot, how many gallons does it take? So if you think about it, if I use my hands here, 1 foot by 1 foot by 1 foot, take a guess. How many gallons? 2 gallons? 1.5? 3. It's actually surprisingly high. It is 7.48 gallons. For 1 cubic foot, so 1 cubic foot equals 7.48 gallons. It is amazing that it's that much. It's crazy. It's nuts. Okay? So now what do we got to do with this? We got to take every cubic foot times 7.48. And that would be no longer volume, but the number of gallons. So we got a choice. We can type that in the way it is, or we can go ahead and calculate that as a decimal. What do you want to do? Calculate it as a decimal? Willow wants to do, so go ahead, Willow. She's typing it in, and she is figuring out what that is. So 7.48 times pi times 12.4 squared, what do we get? Okay. So a surprisingly easy function when we get it all done. Okay? So there's one particular skill that I'm aiming for on your calculator here. So let's take a look. I'm going to go ahead and just 3613.2, and I can't use H. I got to use X. Whenever it's building my graphs, building my tables, it's always going to use X for my input. That's not true. Sometimes it'll use T, sometimes it'll use R, but that's another function in my calculator altogether. So if we graph this, let's think about it. My results are going to be big. My X is not going to be terribly big. So let's set my window. My window, let's go 0 to, 30 foot high. My Y, 0 to 70,000 gallons. Okay? Graph it. Linear, we're not surprised. There's no squares or anything. Okay? So now we can do one of two things. We can just look at a table. We could solve it, obviously, just by writing an equation, but I want to show you this. If I put my target on here as another function, what did it say? 63,500. If I graph that, they'll have that, and now we can calculate our intersection point. Yes? Go back to the window. Okay? So now if I'm looking at my graph, if we go Calc, second Calc, we can do intersection. On this one, algebraically, it's silly to do an intersection with our graphing calculator here because we would just set it equal to 63.5 and solve it. But I'm just trying to show you a skill on this. So if I go intersect, first function, first curve, boom, second curve, boom, guess, boom. There we go. There's my intersection. So that tank would have to be 17.6 feet high. That's a lot of fuel. That's a ton of fuel. So I anticipate that you guys may not believe that. So what I did was I did a little bit more. And here's all the tanks on a boat. See, I love this stuff. I love the applications, okay? We can do skills till we're blue in the face, but this is what I think is interesting. We've got this situation where here, this one right here, that holds almost 13,000 gallons, that tank right there. This tank right there holds 12,000, almost 13,000 gallons. Same thing over there. So these different tanks here and there and everywhere hold the total of 63.5. But there's one tank that's not shown on a 747-400, which is what they're talking about. There's another one back here in the horizontal stabilizer. Okay? So, does that interest you guys or not? Or it's kind of amazing that it can hold that much fuel and still take off. Planes just blow my mind. So this is not due tomorrow, because I'm not giving you any time. But our next thing we're going to do, page 38. So tonight, what I'd really rather you do, you can work on this a little bit. For the trigonometric functions, we need to do a couple examples, and I didn't have time for that today. So I'll have to do a couple more examples tomorrow, but you can get it started on a little bit of that, and then look back on 1.1 to 1.3 to see what questions you might have. Because a lot of times when I see something online, it doesn't look believable mathematically, somebody screwed something up. And there's so many people out there that don't have a fundamental understanding of mathematics. You know what? Tomorrow, we're going to have to do million, billion, trillion.
Okay.
You'll see. It's one of my favorite little lectures and stuff to talk about. Did it?